Normally we can find the percentage composition of a compound by doing a whole lot of analytical techniques on it. And so what you'll often find is you're given the percentage composition and you have to work out the formula. The empirical formula is the simplest ratio of atoms in a particular compound. So it's not always the same as the molecular formula. So if it's an ionic compound, the empirical is the same as the ionic formula, because ionic formulae are exactly that, simplest ratios. NaCl means not one Na and one Cl. It means for every one sodium ion there is one chloride ion. But it's never in a 1-to-1 ratio. You don't have an NaCl molecule. What you have is a crystal which is made up of billions and billions of sodium ions and exactly the same number of chloride ions. That's how it's stable. If, however, you had something like, let's say, hydrocarbons, so something out of fuel, so C6H14, alright, push this up quickly, C6H14, that's not the simplest ratio. The simplest ratio would be C3H7. So that would be the empirical formula. This is the molecular formula, because that actually doesn't exist. C3H7, well, it does, but not as an alkane like that. Okay? So, keeping that in mind, empirical formula is the simplest ratio of the elements in the compound, whether it's ionic or covalent. So what we're looking at here is chromium and oxygen, so metal and a non-metal. So you could quite safely assume it's ionic. So when we find the empirical formula, we're actually finding that formula as well. So how do we do this? Well, we need to make a couple of assumptions. The first thing we think is, well, it's percent, which means per 100. So if I assumed that I had 100 grams of it, then how many grams of that would be the chromium ions? If there's 100 grams of chromium oxide, which is 68.4 would be that. So, if I've got my chromium and my oxygen, and I know that I've got 68.4 grams, well, I can assume that its mass is going to be 68.4 grams in 100 grams of this compound, which means the oxygen must be 31.6. My maths isn't good enough to add up to 100 here. These should add up to 100 because we're assuming they're 100 grams. Well, there's something else I can find out really simply about these things, and that's their atomic mass by using our periodic table. So I'm not going to put it as atomic mass because I like to use the N, seagulls over mountains, triangle. So I'm going to call it M rather than A. It is technically this, but it's easier to think of it in this way here. So if I go to my periodic table and I have a look at chromium as number 24, then I find that the number we're given is 52.00 grams per mole. And for oxygen, we should have 16.00 grams per mole. Well, if I've got these two variables now, I can find the number of moles of each of these. So N equals little n divided by big N. So I do this on my calculator. .4 over 52.00 equals, now my 68.4 is three significant figures, so this number is only three significant figures, 1.32. Do the same thing here, 31.6 over 16.00, and I get 1.975 to 1.98. Now, I can't write a formula as CR 1.32, O 1.98, that's just ridiculous. We're wanting a ratio, it's in whole numbers. So the easiest way to do a ratio is to divide by the smallest number. So if I divide both sides by 1.32, this one's going to equal 1. This one's going to do something really funny. So I'll just quickly do that. It ends up being about 1.5. Well, again, that's not a real ratio because it's got a fraction in it. So what would be the simplest ratio for that? 2 to 3, fantastic. So if I just double the whole thing, I do get whole numbers, which is the same as 2 to 3, which means that if we look at my columns, it's going to be Cr2O3, which is indeed the formula of chromium 3 oxide. So I've found the empirical formula of that one there. Alright? So they're not always it's easy. Sometimes you get 3 things coming out, you've got to sort of play. So I'm going to do one more with you quickly, where we're going to have 65.5% carbon. We're going to have 5.5% hydrogen. And we're going to have 29.0% oxygen, and try to work this one out. The same idea, I'm going to put the 3 elements across the top, C, H and O, and down the side I'm going to put little m, big M and little n. I'm going to assume I have 100 grams, so therefore I have got 65.5 grams there, 5.5 grams there, and 29.0 grams there. Carbon 12.0, hydrogen 1.0, so I'm simplifying these, and oxygen 16.0. I'm simplifying them, this one's only one central place, so it's only 2 cents, so I don't need these to be too precise. So I go again on my calculator. 55.5 over 12 is roughly 5.5. That's 5.5. Well, this is looking convenient. And that, I think most of you see is roughly 2, isn't it? Pretty close. So let's do it properly. 29 over 16. So I get 1.8. Alright. So the smallest number here is 1.8. So I divide every single number by 1.8. So I end up with 1 there. And I get 3.1, which is close enough to 3 for this one. The 3.1 is close enough. Alright? 3.25 wouldn't be. You'd probably look at changing that one. So 3 to 3 to 3. So our formula is C3H3O. And that's how we calculate empirical formula. When we need to find molecular formula, that's where we're given a bit more information. We find out that this one here, sorry, I've got the wrong one. Yep, this one here has got a molar mass. We're told in the question, we're told that it has a molar mass of 110 grams per mole. Okay, that's what it's got to be. Now, if I add up 3 times 12 for the carbon, and 3 times 1 for hydrogen, and 1 times 16 for the oxygen, I don't get 110. What do I get instead? What do I get? So I go 3 times 12 plus 3 times 1 plus 16. Too early in the morning, obviously. What do you get? So 3 times 12, because that's the atomic mass of carbon, plus 3 times 1, because that's the atomic mass of hydrogen, plus 12 for the oxygen, plus 16 for the oxygen. 55. So this one here is only 55 grams per mole. Okay? Well, so how many times is this formula repeated to make that? 2. So if I actually had C6H6O2, that would add up to 110, wouldn't it? So actually this may be the empirical formula, but the molecular formula is C6H6O2. And so that would be our final answer that we're looking for. Because we're given that extra bit of information, we can go from empirical formula across to its molecular formula. With that little bit of extra information.